Sustainability has become a key business driver over the last decade or so, and it's an issue that's vital to the UK's construction sector. Sustainable buildings can make a big difference to the nation's carbon emissions. So the big question is, how sustainable is steel?
As a material, steel's strength, its versatility and recyclability make it sustainable. It routinely delivers sustainable buildings using tried and tested technologies, and importantly in today's climate, does so cost effectively.
Sustainability in the end is making sure that you don't compromise the future, and for us it is about creating quality, creating things that give you a long life and a sort of loose fit in terms of architectural space design. Steel is a great material to enable that to happen because it has this beauty of this sort of rapidity, the ability to be adapted and changed almost at will without losing integrity. And I think it's it's a sort of ductile, malleable and very expressive way of doing that. So aesthetically, I find that very interesting.
From architects to contractors, to regulators and customers, everyone is focused on delivering sustainable structures. What are the main drivers behind that effort?
Well, we've seen many drivers over the last sort of decade or so, but in fact very few are actually mandatory. The rest almost entirely voluntary. Certainly operational carbon has been and remains a priority, and driven really by government's low and zero carbon targets and through part out of the building regulations. Operational carbon remains the key driver, I would say. BREEAM, although voluntary, is also very important and really, I guess, the de facto measure of sustainability or sustainable buildings in the UK, and a lot of private clients are using BREEAM. We're also seeing embodied carbon becoming important. Obviously, as operational carbon is reduced, the relative importance of embodied carbon becomes more significant, and a lot more designers are addressing that aspect of sustainability.
The recession has not slowed the construction sector's focus on developing ever more sustainable building methods and structures. The recovery, in turn, is sharpening the sector's focus on the issue and making architects, designers and contractors examine the case for steel even more closely. Before we look at the argument for steel, let's define what sustainable development actually is.
For most people, sustainability is quite a difficult concept to get their heads around. But for me, it's about creating a building that will go on to enable people who occupy it to effectively lower their own carbon footprints by virtue of the fact that they're working, living in the building that we've created for them. So for many people, for many designers, that's about getting things like the energy of the building as low as we possibly can get it, looking at the materials that it's actually been built from, making sure that there is low embodied energy that they can possibly be, and then looking at maybe how people are actually going to use the building afterwards.
Sustainable development is all about a balance between environmental, social and economic issues. I think all too often people sort of cherry pick single issues out of a much broader agenda. Carbon's a very good example. While clearly carbon's very important, it really is only one issue of a much broader, complex sustainability agenda.
So what's the case for steel? Is it a sustainable building material?
Steel buildings are lightweight and resource efficient. They provide long spans, which provides flexibility. They're adaptable, and importantly, at the end of the life, the steel components are either reusable or 100% recyclable.
So the buildings might be sustainable, but does that make steel green?
Clearly, steelmaking is energy and carbon intensive, but significant progress has been made over recent years to reduce that intensity. And we've actually managed to reduce the energy required to make steel by nearly 50% over the last 25 years or so. And in fact, there's a lot of ongoing R&D looking at how to improve that further. It should also be remembered, of course, that steel is very strong with a good strength to weight ratio, which means a little steel goes a long way. So although on a per ton basis, the embodied carbon of steel might look high, when you assess it over a whole building, actually the embodied carbon is very low.
You can make steel in two ways: from primary materials and from recycled scrap. Right now, around 70% of steel is made by the primary route, as there is insufficient scrap steel available to meet the global demand. The energy required to recycle scrap is much less than that needed for primary steel production. So it is tempting for designers to specify recycled steel to reduce the environmental impact of their projects. But this is counterproductive. It simply redirects the limited scrap from where it is already being used, which introduces inefficiencies in the global steel supply system. Almost all of the scrap steel that comes available is captured, making it the most highly recycled material in the world, with over 500 million tons being recycled every year.
Well, steel is fully and truly recycled. By that we mean when we recycle it, we create a product which is functionally equivalent. So a steel beam can be recycled back as a steel beam. It's a very important distinction, and it's an important differentiator with other structural materials. Concrete, for example, is increasingly recovered, but it's crushed and downcycled and generally reused as a hard core or as a fill material. By doing this, certainly landfill is avoided, but you haven't substituted concrete, so new concrete has to be made.
Once it's stopped supporting a structure, a simple steel beam can be turned into a car body, a fridge, or any other steel-based product, before it eventually becomes a beam again in a new building.
Steel in the UK is recycled at greater than 95%. Really, it's unmatched by any other common construction material. So the question really is, where do we go from 95%? Well, we think we can. Not a greater recycling rate, but moving on to reuse. Reuse is very important because we don't have to remelt the steel when we do in recycling. So by reusing, we save even more carbon. So what we really want to do is encourage designers to think more about how we design for reuse.
Steel is produced as standard components. This idea that you can, those standard components have an infinite lifespan, and actually the idea that they can be used in new situations without melting down and reforming is obviously ensures that it has one quality above its sort of competitors in terms of sustainability of material consumption.
Employing steel in a building's construction means that a designer can even plan for when the building's life has come to an end.
It was actually the contractor who employed a steel specialist who actually said, listen, we can provide you with a steel frame that not only will you have instructions for how to put the thing up without using any welded joints, but everything bolted and connected, but we'll also leave you with instructions on how to take the building down at the end of its life without needing to resort to massive energy input to actually take it down.
It's a strong argument, but isn't it trumped by waste? The construction sector is the largest generator of waste in the UK and is under intense pressure to reduce its waste output. How does steel stack up? What are its waste credentials?
Steel has excellent waste credentials at all phases of the product life cycle. In manufacture, byproducts are widely recovered and reused. For example, blast furnace slag is used as a cement substitute. In the fabrication process, offcuts and swarf, etc., are easily recovered and recycled back into the furnace. And of course, because steel products are all off-site manufactured, there is zero waste on the construction site. And of course, at end of life, when we demolish buildings, steel is easily recycled or reused at 95%.
In terms of operational carbon, the concrete sector makes strong claims about the benefits of thermal mass. How does the steel sector respond to these claims?
Thermal mass has an important role to play in reducing carbon emissions and improving thermal comfort in certain building types. Where we disagree with concrete or the heavyweight sector is the need to build really heavy, massive structures to take advantage of thermal mass.
Independent studies agree that when you take into account the daily cycle of temperatures in the UK, the optimum thickness of concrete in upper floors is only around 100 millimetres. All flooring systems commonly used in steel frame buildings exceed that. So a well-designed steel frame building can deliver the same thermal mass performance as an equivalent concrete framed building, and do so with less than half the thickness of the concrete in the floor slab.
Because of the fantastic capacities, of concrete to absorb, the amount that we actually need is probably only 2.5, 3 inches in thickness. We don't need vast 500 or 600 millimeters of concrete as might be in some buildings.
Sustainability is a process, one that will continue long into the future. It's a battle to deliver what we want and need as a society, against the desire to reduce carbon emissions and reverse climate change. What is the steel sector doing to make steel even more sustainable in both the short and long term?
Steel sector has done and is doing a lot. For example, in terms of production under the ULCOS project, which is a large European R&D program, we're investing something like 75 million euros over 5 years to reduce the carbon emissions from steelmaking by up to 50%. In the UK, the steel sector is also doing a lot. Many of its members are signed up to a sustainability charter. We manage and measure our carbon footprint, and we're increasingly producing environmental product declarations about our products.
Studies show that steel works, that it enables functional, flexible, attractive and ambitious buildings to be constructed all over the world. It helps to make sustainable buildings and bridges, both in terms of the way they work day to day and over the long term. And the steel itself has the ability to be endlessly recycled. So can we conclude that steel really is sustainable?
There's no doubt that steel is a sustainable material and a sustainable construction system. As a material, it is strong, it is versatile and infinitely recyclable. And as a framing system, it delivers the demands of modern clients and, importantly, does so cost effectively.